Have you ever wanted to connect the virtual world with the real world? There is a million things you can do with hobbyist electronics to either measure and control the virtual world with it, or take the virtual world and use it to control the real world. In this tutorial, we're going to be discussing the bridge and how to create the communication between Blender and the Arduino hobbyist development environment for both controlling and measuring things in the real world. This ability is going to make it so that you can do all sorts of projects. You can do things like making your own controller to control objects inside a Blender or your own 3D scanner. We're going to take this distance sensor hooked to an Arduino, we're going to point it at a flat surface, and we're going to use the microphone and speaker to project sound back and forth from the surface to the sensor. And then we're going to have Blender ask the Arduino for the distance between the sensor and the surface, and then it's going to return that measurement into Blender and move an object inside a Blender. Now, this may seem really simple to you, but this is the foundation for doing all sorts of amazing things, such as making your own motion capture suit. I had planned on making someday a tutorial on how to make this entire suit and to use it, but I thought, why not start with the basics and do something simple to show you how I started down my road to making my own suit. So let's get started by making a cube move up and down. So this is an Arduino Uno. The Arduino is a $25 USB device that you can purchase, and it's kind of the hobbyist standard for taking signals from the real world and converting them into your computer. They're quite cheap. You can buy a genuine Arduino for $25 or $26, and a cheap knockoff can be about half that in price. Basically, this is a microprocessor on the Arduino that talks to your computer, and the way it does that is with a serial port. So if you connect a USB cable to your computer, basically this device can communicate directly to Blender using a thing called a serial port. Think of a serial port as a device that will send text down the wire and into this processor, and this processor can send text back again. So it's a communication path between the computer and Blender and the outside world and anything you would want to connect to this Arduino. There are all kinds of sensors that you can hook up to an Arduino. Just Google Arduino sensors. You can hook up temperature sensors, motion sensors, anything you can think of with example code online for the Arduino. You can even hook up a joystick and control Blender with a joystick if you'd like to. To get the Arduino environment installed on your PC, just Google Arduino IDE and follow the instructions on the page to download the integrated development environment to your computer and install it. On Linux, sometimes it has security issues with COM ports, so beware of that. Google how to fix that issue. It's a command line update to Linux, but you Linux guys probably know how to do that anyway. So I've downloaded and installed the Arduino IDE, the integrated development environment, and I have my Arduino here, and I was going to plug it into the computer in just a second, but before I do, I wanted to check some settings first. So if you go to the tools area, you can look and see your port, what port is selected for your Arduino to be on, and I haven't plugged it in yet, so it's a good idea to note which COM ports are already on your computer before you plug it in. And we know we're going to be using a different board, so our board is actually going to be an Arduino Genuino Uno, which if you bought a different board or you want to use a different board, you can pick it from the list here, but I've got an Uno. Now I'm going to plug my Arduino in, and I just plugged it in. And I'm going to go over to the Tools section now, and I notice that COM6 showed up. So I'm going to select that COM, and now I connected to my Arduino, and we can do a quick test to see if this is going to work. So when you're programming in Arduino, you have a setup that runs once at the beginning, and then there's a loop section that runs again and again forever after setup has run once. So to write a quick program to test to see if it works, you can first of all go to File, Examples, go to Basics, and you can load a program called Blink. And if you can verify to compile the code, and you can upload it. So I'm just going to click to upload this into my Arduino Uno. And when it's done compiling and installing it on my Arduino, which it just did, the lights on my Arduino are now blinking. So I just verified it worked. So I'm going to get rid of this. I don't need that anymore. And I'm going to write a quick program to talk out the serial port. In this next section, we're just going to program the Arduino to send the word hello down the USB cable into the computer again and again forever. This will test the communications from the Arduino to the computer. In the setup, I'm going to tell the serial to begin, and I'm going to give it a speed, and I'm going to make it 115/200. Just use that. There's lots of different speeds you can set a serial port to, but 115/200 is the fastest, so that's the one I like to use. Fastest for a real port. They've gone faster in recent years, but I'm too old to know what they are. Then what I'm going to do is I'm going to print a line, and it's going to be print line. And we're going to say hello. Now, when I compile this sketch and put it into the Arduino, it's going to begin the serial port and then just start printing hello out of it. There's a serial monitor that allows you to see what's coming out of the serial port right here, and you can see hello is being printed as fast as the screen can display it at 115.2 kilobaud. So that's the speed. So we can see that our Arduino is able to send text out as fast as it can inside the loop into the computer. So now we're going to actually send some text, the text hello Arduino, out of the PC and into the Arduino. The Arduino is going to parse that, and then it's going to respond to the text by saying, "What is thy bidding, my master?" In this way we can demonstrate how we communicate back and forth. You might wonder how I figure out all this code. I just Google Arduino serial port commands and then read blogs and do things until I figured it out, because I never remember. So don't worry about me knowing it and you not, because you can always Google all this stuff. So what I do at the top of the code is I create a string variable. You can actually assign values to this variable anywhere in your code and then print it out or use it to determine what you're going to do with the string that came in. Next in the code, I set that string to empty string so that it's doesn't have anything in it when we start in the setup routine. And then down in the main loop, I am going to read the bytes of the port and assign it to that string. Okay, so I'm going to describe this section, and hang with me because it's a little bit, but it's not too bad. If serial available greater than 0 means that, hey, some data has shown up on the port. We don't like to read things from the serial port unless something has actually shown up on it, so we're not wasting cycles of the processor looking at a serial port that doesn't have anything on it. So the serial available returns greater than 0 if there are bytes or data showing up on the port. So everything inside of the if statement is going to execute if data shows up on the port. So we take our command from PC variable we declared above, and we read a string until we get a new line character. The new line character is the end of the string. So when you hit carriage return and send a string into the Arduino, that's when it stops reading. If it doesn't get that data, it'll go ahead and time out. Timeouts are bad because they delay your code unnecessarily. We want to read until we get some determined end of the string and then move on with our code so we're fully optimized and not sitting around waiting. In this section, we respond and check the string and do different things based upon what the string is. If the string happens to be equal to "Hello Arduino," we respond with a string out the serial port called "What is thy bidding, my master?" I changed that from hello just for fun from the previous code. So anyway, let's test it out and see how it works. So now I'm going to go ahead and compile my code and put it into the Arduino. And it just compiled, and now it's uploaded. So I'm going to open up my serial monitor to take a look at what happens when we run our code. And notice it doesn't say hello forever now because it's waiting for something to receive on the serial port. So I'm going to type the word hello Arduino in, and I'm going to hit carriage return. And it says, "What is thy bidding, my master?" Now I have changed the end of character to new line, but if we have no line ending and we do the same thing again, notice it waits a second and then it comes out because it never received a new line. It has to wait for the timeout to get it. So to optimize our code, we change the line ending to new line, then we can type in hello Arduino, and it comes right back, and our code is working quite quickly now. Okay, so now that we have successfully communicated back and forth from an Arduino inside of the Arduino environment, let's do it from inside of Blender. So to set up Blender to work with a serial port, you have to actually add a library that allows you to talk over COM ports in the Python inside of Blender. So I googled PySerial, and this is the page that came up, and then you can just download the files here, and then if you download the zip file, or it's a tar file, you download it. I'm going to open it, and then I get inside of here a PySerial tar, another one, and go inside of there, and there is a serial folder inside of this. All you have to do is go to wherever Blender is, and if you click on your shortcut and you go to Properties, and then you open the file location to wherever Blender is the executable, you can go into your versions folder, go into Python, go into lib, and if you take this folder, the serial folder, and put it inside of the lib folder, I need to scroll down here so it doesn't put it inside of another folder inside of there. We put it in, and now there's a serial folder inside of the Python lib folder, and now Python inside of Blender knows how to talk out serial ports. Okay, now that I've Googled PySerial and how to do a serial port in Python, I've remembered all the commands, so now we're ready to try talking to our Arduino in Blender. So let's open Blender and go ahead and try the script. So I'm going to go to the scripting tab, and I'm going to make the script quite large so you can see it. And we'll make it nice and big. So now this is the Python console in Blender, and what we're going to do is we're going to go ahead and import the serial library that we just added into Blender's Python directory. And now Blender knows to use the serial library in the next commands. We're going to create a variable called SR for serial, and we're going to assign to it the serial port that we start with the following command: serial, and then remember we used COM6 in the Arduino IDE. So we're going to use the same COM port here, and we're going to set the speed to 115/200 just like we did in the Arduino IDE. And when I press enter, it will go ahead and adds that serial port and assigns it to the variable SR. Then we're going to write SR.write is the write command to the serial port, and we're going to write a string. Strings in Python require a B with a dash. And we're going to type hello Arduino, and then we're going to put our new lines so it runs quickly, and then we press enter. And now when we go hello, we're going to create another variable called hello, and we're going to take the SR variable we called before, and we're going to read a line from the port. When I read the line, it's going to assign to the variable hello whatever came back after we did the serial write. And then we're going to print hello. We're going to see what it says. What is thy bidding, my master? Exactly what we put in our Arduino. So now we are talking to the Arduino inside of Blender. How cool is that? We can do anything with an Arduino inside of Blender. Anything we want. This rocks. This is an SRO Force Sensor. It has a speaker and a microphone built onto it, and you can use it to measure the distance from the sensor to any object. It transmits out a sound wave, and it can tell you the distance between the sensor and a local object. The Arduino is going to send a trigger pulse into the sensor, and it's going to then send an echo pulse back out the green line into the Arduino. The Arduino is going to time the amount of time it took between when it triggered it and when it received the pulse. And after it's done that, it's going to take the measurement and send it back to Blender. So I'm going to take 1 minute in the tutorial to show you a really cool program called Fritzing that allows you to diagram out how you're going to wire up your Arduino project. I've downloaded and installed Fritzing. It's Fritzing. I click on the breadboard tab, and built into Fritzing is all of the Arduino components that are common out on the market today. So here's a nice diagram of my Arduino Uno, and we are using an SRO4, which it remembered since I searched for it previously, and there it is. So we bring this in, we can zoom out just a hair, and then we can hook 5 volts to VCC, and we can hook ground to ground, and we're going to put D2 into trigger and D3 into echo. And all you need to do to change a wire and make it look prettier is to click on it and drag a little right angle piece in so you can make your wires look a little prettier. And if you right click on a wire, you can change its color. So we're going to make this one yellow, and we're going to make this one green, and ground in electrical is always going to be black. And you can clean it up just a little bit more than I do, but we're going to make the power our red, and we now have a wiring diagram for what we're going to wire up our Arduino and our sensor. So this is our code so far, and we want to go ahead and add the SRO Force Sensor and have it take the reading when we command it to from inside of Blender. So to do that, I could try and figure out how to code it all myself, but why when you can steal someone else's code? I mean, that's why you're watching this video, right? To steal my code, right? So I went to the Arduino Project Hub, and they have a section on how to write code for our distance sensor, and I'm just going to steal all their code, and they have some great documentation. They've wired theirs slightly differently, but we can easily modify that, and I'm going to steal their code so that we can, that's the wrong one, so that we can basically do the same thing that they're doing. So I'll go ahead and put this up and have this one go over here, and we'll go, okay, so at the top of their code, they're declaring 2 trigger pins. So I copy those, and maybe if I drag them over, does it work? Yeah, it works. Cool. Let's drag and drop. So, and then I have a new float called duration. So we're declaring, this is their declarations of the variables they want to use. And then they already have a serial begin, and they're using a slower speed. I don't recommend that, but we still need to declare our 2 pins that we're going to use. So I'm going to put that right up here, and I drag and drop that right there. And then this is the point at which they actually get the distance from the distance sensor. So this code, then they calculate, then they get the duration, and then they calculate it, and then they print the distance. So we're going to steal all that code, but we don't want it to do it when we say hello Arduino. We want to do it when we receive a different command. So I'm going to steal this if section right here, and I'm going to copy it, and then I'm going to say else if, and I hit Control V, and we're going to put in, instead of receiving the command hello Arduino, let's say get distance. So I need to put some new brackets in for this guy, and then we put it automatically put a close bracket in for me right there. So if we get hello Arduino, it's still going to return what is thy bidding, my master. But if we get a command called get distance, we're going to go ahead and put the code for getting the distance and responding in here. And so what we do is we grab this little section that writes the trigger pin high then low, and we need to tab that in. And indentation is critical in all of your code. It's very easy to miss a bracket, and you won't see it unless you indent things correctly. So to calculate the distance, we take the time, and they use the speed of sound to see how much time it took for the sound to travel away from the sensor and back, and they divide it by 2 because it's a two-way trip, and so it takes to and from to determine the actual distance that we want. And then I'm not going to print the word distance colon at the front. I'm just going to be printing the line distance. So I put that in here as well. And now in our code, when we say get distance, it will pulse the trigger high-low, calculate the duration, or get the duration of that in clock counts, and then they multiply and do some math to get the actual distance, and then they print it out. So let's load this into our Arduino and see what happens. So I'm going to load this into my Arduino, and while it's loading, I'll point the sensor up at the ceiling, so we'll see how far it is to the ceiling. And good, it doesn't look like I got any errors. And I can open up my serial monitor, and I can say hello Arduino, and it says what is thy bidding, my master. But now I'm going to add get distance, hit enter, and it says 0. And I know why it said 0, because they're using pins 9 and 10, and we didn't wire them on 9 and 10. We're going to do it on 2 and 3, so that was my mistake. I'm going to re-upload the code. Yeah, you just have to iterate your way to working code. And then we say hello Arduino, and you say get distance, and it's 156 to the ceiling. I'm not sure what the units are, but if I move it closer to the ceiling, let's see, say get distance, and I move it closer to the ceiling, and I hit enter, I get 100 instead of 156. So it's working. We're done with our Arduino code. Now we can go back to Blender. Okay, so we get to have a lot of fun and land this plane and finish the Blender scripting. So I actually did this tutorial already once, and I typed all this out, and it was really boring to watch me type. So rather than doing that, I thought I would just show you the code and walk you through it. This is the same SIR equals serial serial you saw previously, where we open the COM port at COM6, and we put a time.sleep3, and this command allows or tells Python to wait 3 seconds for the Arduino to boot. It's not going to accept commands or do any communication unless it's all fully booted. So we give it a chance to boot by doing that. And I just Googled how to wait in Python, and that's why I imported the time library, was just to do this time sleep statement. And I can always test my stuff over here by going time.sleep3, and I hit enter, and the whole thing freezes for 3 seconds, and then it's done. So it worked. So then after I have opened the serial port, I'm going to write, and this is the same write command we used previously, but instead of hello Arduino, I say get distance like we did in Arduino code earlier. And then I'm creating a variable called start, and I'm doing a SRO read line. So I'm reading a line, the response, which is going to be the distance transmitted by the Arduino. I'm converting it to a float variable with this float command. So I'm going to start my entire thing by getting the distance and reading the start. This line I got by basically selecting the object in the scene, and then in Python you can come over here and you can say, and I googled how to select the current object, but also you can go bpycontext, and then if you hit the tab key, it'll show you all of the commands that are available for context, and I know that I want the selected objects, and if I hit the tab key again, it auto-completes it for me and puts it in. So I'm going to want the first selected object, so that's the 0 iteration of the selected objects, and if I just press enter here, it tells me that the first selected object's a cube. So I'm actually going to go assign a variable to cube equals, and now if I type in cube, I get the same response. So I've assigned that variable. So I took this line and copied it and pasted it up here once I'd figured out how it worked over here. So when you're writing Python, that's a good idea to do. The for loop will basically just run 500 times. So we're going to do it for 500 times in a row, and we're going to serial write the get distance. We're going to create a new variable called current, and this will get the current position, and then we're going to print it out so we'll see what it is. But then we're going to go, okay, well, I want to set the cube dot, and I can hit tab here and go, oh, scroll up here and go, oh, they have a command in here called location right here. So I'm going to go ahead and use that location, and if I type location and hit enter, it gives me the location, but I can say cube.location.z, and that gives me the z location of the cube. If I say cube location z equals 10, and I press enter, you notice my cube moved up to 10 increments, and I'm going to clear that out. But basically the cube location z will set the vertical position. So my vertical position is going to be the start position of the sensor subtracted the current. So it's going to be the difference between where I started with the sensor hanging in space, or the distance from the ceiling, and where it's currently moved to. This line right here is a hack from Blender that will redraw the screen in the middle of the script. And this allows, if normally when you run a script, Blender freezes, you don't get any user interface interaction. But if you put this line into your script, it will redraw the GUI and show you where the cube is. And then if you hit serial close, it'll close the serial port when it's all done. So let's test it out and see how it works. Okay, so I just went to test this, and it turns out that I forgot the new line character at the end of these two, so it was running really slowly, and after I spotted that, I fixed it. So now I'm going to show you what it looks like to actually run this. So go ahead and run the script. It connects to the Arduino, and the cube goes up and down with the sensor.